Let's look at another kind of data visualization tool that we won't write code for in Python, but that gives us an example of the kind of project that you can do using large amounts of data and some programming framework to provide people with results that they can use to make decisions or do analysis or things like that. That is the Google Ngram system. So this gives us an example of a large-scale application that was data-driven, meaning that they had to generate large amounts of data, and thinking about the data is the main purpose of the application. We use it to analyze data, to visualize data, much like our Python programs did with the graphs in Matplotlib. This program is driven entirely by that idea of accessing some data and providing tools for analysis and visualization of it. It is public use, meaning that it's available to the public. And it's one large technology project put together by Google in collaboration with other organizations. So the idea of how it was done is that Google allowed employees to use 1 day's worth of work a week, and they continue to do this as far as I know, to do projects that don't necessarily make profit for the company, but are things that the employee is passionate about or that might benefit society at large. Open source projects, educational projects, things like this. In fact, this is where we get the inspiration for our passion projects in this course. So Google worked with different libraries and publishers and archives like the Internet Archives and the Library of Congress and things like this. They digitized books and other materials, other written materials, using specialized scanning equipment that they helped to develop. Now, there were existing technologies for this kind of scanning, but they helped to develop ones that specifically worked for this application of large-scale digitization of books and other written materials. Once they had scanned things, they used optical character recognition, also referred to as OCR, to turn those scanned images into actual searchable text. And you have probably seen applications of optical character recognition in other settings. For example, applications that can scan a check and determine how much the check is written for and send it off to your bank to be able to deposit use optical character recognition, because the picture of words is not necessarily usable to the computer. So there's an extra step along the way to take those characters and recognize them in the picture. OCR is not perfect, and so often when these efforts are done, either by Google for the Ngram system, or, for example, another big project that does these sorts of things is called Project Gutenberg, where they tried to scan in all publicly licensed books, meaning books primarily where the copyright has run out on them, and therefore they wouldn't be very profitable, and so they might get lost to time if they weren't archived in some way. So they scan in large amounts of books and text, and it's not perfect. So sometimes it means that low quality data has to be thrown out, and sometimes it means that there need to be humans in the loop to confirm that the character recognition was done properly and that the actual resulting data is accurate, so that when it's used for analysis, like the Ngram system does, or when it's used to, say, read books aloud to individuals who have lower vision, or just to people who want an audiobook, that it's actually correct in those settings. In addition to just scanning in the data, they then also recorded metadata. Metadata is information that describes data. For example, the title of a book is metadata about that book, the year in which it was published, the genre, the author. All of these things are not necessarily part of the book's contents themselves. They are information that describes the book, and therefore they are metadata. Then they designed and developed a web interface that allows people access to the metadata and the data to use it and do analysis. So here's an example of a piece of OCR hardware that takes a book and can flip the pages in it and can create images of that book. And then the computer will run algorithms to do the actual optical character recognition from the images. And the algorithms that work for this, they range pretty broadly. There are some algorithms that will just straightforward do image pattern matching, that a curve in this particular shape is just determined to be the letter C, no matter what. But there are other algorithms that use logic systems and use sort of inference to tell what makes sense in that sequence of words or in that sequence of characters. Does this C here actually spell a recognizable word when combined with the characters next to it? Does it make sense in the context of the sentence? And these algorithms are really quite complex. Dave Barbella here on campus does natural language processing, which is one of those types of algorithms that can be used to determine if a word makes sense in its setting. So that, for instance, if a book was being scanned in and you saw this shape that looked like a C, but there's a chance that maybe some of the ink got rubbed off on that page or that it never printed properly, and therefore that really was meant to be an O or some other letter, you could infer that from the context. So OCR and the associated hardware and algorithms are actually a wide range of different technologies. And this is just an example of an application of them. If you're interested in the algorithms, there's tons more ways that you could dig into those sorts of concepts. So here's one example of an Ngram comparing the terms Star Trek and Star Wars. It compares from 1900 to 2019, and it compares English results. It is case insensitive, meaning that it would ignore whether the S and the T were uppercase or lowercase. I just typed them as uppercase. And similarly, it would ignore the S and W being uppercase or lowercase, so that if these were used as the names of movies or shows, that would count, or if they were used as just words, then that would also count. And then there is some amount of smoothing to smooth out the curve, because these numbers will vary a bit within a year and between years. So if we look at this, it displays that between 1900 and 1940, there are almost none or no uses at all of either of these terms. We see a small bump for Star Wars, because that's the red line, in 1940 to 1950. And this is where we can use this visualization to start to do some thinking. So why might there have been some use of the terms Star Wars, whether it's capital or lowercase, is again ignored. So maybe, for instance, it was being used in a lowercase sense of battles over getting to space during what was referred to as the space race time period in here. Maybe this was people planning for space exploration. Maybe this is science fiction novels starting to think about fights in space settings, and so it was coming up there. So we might start to think about some explanations of that. And then as we see, for instance, when the movies Star Wars started to come out, then they start to show up in the kinds of data that Ngrams display, which is books and written materials. So the movies come out and there is writing being done about them in books, newspapers, magazines, things like that. Similarly, Star Trek started existing as a show, and it starts to become more and less popular. And you can see time periods in which, for example, Star Wars was not as popular. And we could start to make inferences again about the new trilogy being released and Star Wars becoming more popular, and later periods, maybe other events leading to Star Wars becoming more popular again. And so this is the kind of thing that you can do, and you can use this to think not just about, say, media like Star Trek and Star Wars, but concepts like justice or peace. And we could think about which of those is more prevalent in the popular context and in these writings that we're examining here. And so you can use this data and this tool to start to think through some possible answers to questions. And you'll be asked to do that in the Ngrams lab. You'll have to design your own choice of an Ngram to generate, and then do some thinking about what the results might indicate, like my example of Star Wars and Star Trek. Why was Star Wars less popular in 1992 than Star Trek was? And why did Star Wars become more popular in the 2000s than Star Trek did? It's also important to think about, does the frequency of the word necessarily indicate that, say, people were thinking about it more? Or does it indicate that paid advertisements about it were being published more? Not necessarily that people themselves cared about it, but that there was a lot of money put behind it. And that's a different situation than whether the average person on the street cared about it. So there's nuance to this that you will always have to do when you're thinking through algorithms and what they are useful for, and when you're thinking about using the results that come out of technological solutions like algorithms and data visualizations. When you write your Ngrams lab report, one thing you want to pay attention to is replicability, that someone else could look at the report that you provide and that they could repeat that same experiment, that same analysis that you did. And they may not draw all the same conclusions, but at the very least they could say, yes, I see the same data and I see the same patterns in it. So we would want to think about exactly what you did to generate your Ngram, your result here. And in general, when you're doing experiments or research, you want to think about all of the steps you took that were important in getting to the result that you got to. So in the example of Ngrams, there are many different settings to it, and there are many different choices that you could make for what those settings should be. And you should really think about which ones are important to being able to ensure that someone could replicate your results and maybe either try to do a different angle on the analysis, or at a later date, say 10 years from now, come back and see if the trends that you described repeated themselves or if they followed from the conclusions that you made. So another thing that you want to do in your Ngram lab is to try to give as much as possible an objective description of the results so that the data and the patterns are described in a way that people could generally agree upon. In the example shown here, we show the word groovy, and we see that it has very little use, but some, up till about the 1960s. So we don't talk about why it has or does not have those uses at this point. We talk about what we see in the patterns and in the numbers, that it may have started to have some usage, but not a very popular usage, toward the turn of the last century, the 1900 turn of the century, and then that it starts to have significant popularity in the 1960s, dropping off abruptly in the 1970s, and then returning to some extent to some popularity in the 1990s and 2000s, or up to 2000, without quite reaching the popularity that it did in the 1960s. That kind of analysis is the sort of thing that we could all agree upon from seeing the numbers and the shape of the graph here. Then, because we always come with our own analysis and our own conclusions and interpretation, and the goal is to do some analysis and interpretation, then we go forward to do that. So here we can state things like that we think that groovy was not very popular as a slang term until the 1960s, and that its non-slang usage was never really widely used. We see that it was used some, and that probably this was for sort of a formal definition of something having grooves. And we could think about why things with grooves might be more common in the mid-1800s and early 1900s than before then. But it didn't have much popularity before that point, and we could conclude that that's because it was not a slang but a formal term that wasn't very common. And then we could talk about this period where it becomes more popular. It became very popular as slang in the 1960s, and then after it stopped being a popular slang term, that later, at a later point, it became sort of retro and sort of a fun way to refer back to this past idea, and so it became a little more popular again. Now, that said, we shouldn't just wildly speculate in these cases. For example, our claim that it was not popular as a slang term, or if we were to say even more explicitly it was not used as a slang term until the 1960s, we should back that up by actually looking into the text and the research on this term and finding out when it was used in 1890. Was it a slang term or was it a formal term? And the Ngram system does actually allow you to do this, to look at some of the uses in context and find that out. And so you should find references either through the Ngram system or through looking up other resources on this, reliable resources. If you want some help in evaluating resources and in doing this kind of analysis, librarians are excellent at doing this kind of thing, looking for sources and evaluating them and things like that. The Writing Center would be a great resource, for instance, in helping you to evaluate your sources and decide if your lab report actually draws reliable conclusions from the patterns that you see in your Ngrams. So, repeating what I was saying, just because your interpretation is subjective doesn't mean that it should be unsupportive. I can't claim that this change in 1880 to 1900 had something to do with new piracy laws, unless I could actually, and that pirates used grooved swords, unless I actually had a source to back that up, or some real reason that I was making that conclusion. It's also important to remember that we can't typically prove a causal link between two things just because the data follows a similar pattern between the two things. But we can still back up our conjectures with evidence. A classic example of the not being able to prove a causal link, going back to pirates, is that if you look at the increases in global temperatures, they tend to correspond to the decreases in the number of pirate ships present on the ocean. But that does not mean that we can conclude that if we put more pirate ships on the ocean, that global warming will go away. And so just because two things correspond or correlate does not mean that they are causal, that one causes the other. So, for example, in my Star Wars, Star Trek, I can't assume that those popularity differences between the two are caused by one stealing fans from the other. I can only say that one became more popular and the other became less popular. And I could make some conjectures about it, but I should be clear which things are subjective and conjecture-based and which things actually have some proof to back them up, what proof I can make for even those conjectures that I make. When you're writing these, the neatness and style matters. It's important to make sure that your writing about science and research can be understood. And so you should give titles and headings to sections of things. You should proofread. When you include graphs or other visuals, you should make sure they are scaled in a way where they're readable, that you've zoomed in where necessary, or that you make it possible in the documents that you create for people to change the scale, and that you provide labels and legends for what is displayed there. The Ngrams show this with labels for each line and with the axes shown. The Ngrams, for example, I would criticize as not having the axes very well labeled for which year something happened in. These are numbers, but can you tell their years? And these percentages, what do they indicate? And so when you create visuals, or even when you use an Ngram, you should make clear either with a text explanation or by modifying the image to show what the different axes are indicating, what their values are. And again, I cannot overemphasize the value of the Writing Center and the library in general as a resource for making sure that you have good quality writing and that you've used information well, because their job is information analysis and information science. So the point of this Ngram lab is to do some thinking about how we evaluate data and thinking about what explanations there are for the changes in the rates that we see, and when those different terms appear. And there always are many different explanations. Some are better supported by evidence than others are. So some questions you might ask yourself when you're looking at an Ngram are, what kinds of things were people commonly talking about during the time periods displayed on that Ngram? How are they talking about it? In other words, are they talking about it formally, informally, as slang, as a professional term? What emotions or other concepts might be attached to it? And then also an important question is whose words are being included and whose words are being left out. For instance, when talking about slang terms, there may be less inclusion overall of slang terms than other terms, and there certainly may be some racial or economic bias in whose, slang and common ways of speech make it into published works. And so you have to understand that an Ngram, when it's based on published works, may not include the full picture within itself because of the structures that exist behind what data was fed into it. If we recorded words on the street, we would probably get a very different set of results than we get from published data. Here are some sources that might help you to do some of your work with Ngrams, and certainly you will find your own sources specific to the concepts that you explore and the conclusions that you might try to draw. But there is the Ngrams tool itself, and then there is an information page that will give you some more information about Ngrams. So this will give you some information about how to use the tool effectively, and once you're familiar with the basic functionality of the tool, then you can start to look a little more into the details of how people have used it in the past, or some suggestions or guidelines that are made available to you at the information page there.